Hello everyone. When dealing with derivatives, the first thing that comes up is using the simple power rule. But sometimes the function itself needs to be manipulated a little bit before we end up using it. For example, suppose that you have the function f of x equals 1 over x squared plus x, and the whole thing squared. Now the way that it is right now, you're thinking maybe chain rule, product rule, quotient rule, something of those things will be needed. But wait, if you do this very simple thing, before you even take the derivative, of moving this denominator on the top by just switching the exponent, now you can recognize that this is simple power rule. So basically, minus 2 comes down, and is raised to the minus 3. But then, of course, you have to multiply with the derivative inside because of chain rule, giving you finally minus 2 x squared plus x to the minus 3 times 2x plus 1. And if you want, you can move this with a negative exponent again in the denominator. All right. So this is a much faster way to do this derivative than just, trying to do some sort of quotient here. Similarly, over there, you have f of x equals 1 over square root of x. Again, before you even take the derivatives, you can view this as x to the minus 1/2. The 1/2 is responsible for creating the root, the minus for putting it in the denominator. Therefore, now when you take the derivative, it's actually, again, quite simple. The minus 1/2 will come down, and this is going to be reduced by 1. So minus 1/2 minus 1 will give you minus 3/2. And again, you may want to rewrite it and put the x in the denominator as follows. You put 2 times x to the 3/2, or even change it into roots and exponents. So basically you get minus 1 over 2 square root x cubed. The denominator becomes the root, the numerator becomes the power. Now, another typical example here in derivatives is how do you take the derivative of this, and once again, you don't really want to use quotient rule. So instead, again, use some properties of the exponents. Basically, this is x squared divided by x to the 2/3. Once again, this becomes a numerator, this becomes denominator. So now you have to combine, and you get x to the 2 minus 2/3. Because they have the same base, so you just subtract the exponents. Or even, this is 6/3 minus 2/3, which will give you x to the 4/3. So now when you're taking the derivative, this is straightforward. 4/3 will come down and is going to be reduced by 1. So 4/3 minus 1 is the same thing as 4/3 minus 3/3, so x to the 1/3. And again, you can switch it back to a cubic root. All right, so before you even take the derivatives, use these simple exponential manipulations. Basically two things. When you have a fraction, something like this, you can rewrite it with a negative exponent. And when you have a root, something like this, you can write it as an exponential fraction. And of course, combinations of those.